students. Today we are going to see the work done. So the work done is given as work done. So for this we consider one point charge in an electric field, and we derive some formulas. So how the work done is going to process. So work done is said to be done. Work is said to be done when the test charge is moved against the electric field. Okay, so for this we'll consider a point charge Q1, and its electric field E, and its electric field E. Okay, so it is represented as, so here it is a Q1 is a point charge, and we have all the directions, the electric field. Okay, and I will place one test charge QT, it is also a positive charge. Q1 is also a positive charge. So due to these two positive charges, it will repel. So the repulsion, I can take it as in this direction. This is the repulsion. Then the force is L. So the repulsion in the direction AL. Okay. So then what is the displacement? The displacement of charge from Q1, I will consider it as DL. So this is the repulsion force FL, and the point charge moves a DL distance from the Q1 charge, positive charge. So according to Coulomb's law, Coulomb's law, the force exerted by the field E is given by F force is equal to the charge QT and the electric field E in terms of Newton. Okay, so this we can call it as some equation number 1. Then, but the component of this force exerted by the field in the direction of DL, is responsible to move the charge QT through the DL distance. So the distance moved is DL. Okay, then the component of the vector in the direction of the unit vector is the dot product of the vector with that unit vector. Means the direction of force this direction of this force is in the direction of AL. So this AL and this force F becomes the dot product. So the FL force is nothing but it is the dot product multiplication of this force and the direction of AL. Okay, so this we can also write as QT electric field E dot AL direction. So this is also in terms of Newton. So this you can call it as equation number 2. Okay, next, then this force is responsible to move the charge of QT through a distance of L in the direction of the electric field. Then to keep the charge in the equilibrium, to keep the charge in equilibrium, comma, it is necessary to apply the force which is equal and opposite to the force exerted by the field in the direction of dl. Means some force should be applied in the opposite direction to keep the charge in the electric field or in the equilibrium state. So the applied force is given by force applied. The force applied, it is nothing but in the reverse direction, means negative of FL. So this is again QT E in the AL direction. It is also in terms of Newton. This you can call it as some equation number 3. Then so you need to keep some note point. Thus keeping the charge in the equilibrium means we are moving the charge QT to the distance dl in the opposite direction to that of the electric field, hence the work is done. Thus there is an expenditure of energy which is given by the product of force and the distance. Hence mathematically the work done by an external source in moving the charge QT through a distance of dl against the direction of the field E is given by what we need to write here. We need to write the equations for the work done, that is W. So I will write it as some differential work dW is done using this applied force into the distance dl. Okay, so this gives what? Minus QT E into AL into distance dl. So this you can call it as some equation number 4. So but this dl into AL, it is nothing but the distance vector. Okay, so but dl into AL, this we get it as some dl, that is distance vector. Okay, so therefore we can replace our dw, it is nothing but minus QT E dot dl vector, and this is measured in terms of joules. Okay, this you can call this as some equation number. This is some equation number 5. This is the equation number 6. So thus work done over the distance of initial position to final position we need to find. So this is the small distance of dl. So if you want to take it for the some initial to final distance we can take. We need to do the integration on the both sides for the differential work done. Therefore W is nothing but integration initial position to final position of small work done dw. So this is nothing but integration initial to final minus q e dot dl. Okay, so I have taken here q because we can not only take the test charge, we can take any charge which represents the q value. Okay, so the q is constant term, so I will take it as minus q, charge is constant, so integration only for initial to final with respect to E dot dl. This is in terms of joules. So this you have to remember. This equation is very important. Okay. So further we will take in the next class. We have the line integrals and all. Then we will continue in our next class. Thank you.